So now that we have our window correct, did we finally get it correct? Now we can press enter and see eventually. Does that look the same? Can you see all three of the graphs? That's pretty close, isn't it? What's the only difference? The given one's a square, isn't it? And I can't change the size of my given window in my calculator. It's going to be a rectangle. Okay, so if I stretch this one out a little bit, would they be the same? Yeah. Okay. So use the functions to complete the table. Oh, well, that's easy, isn't it? Now I could say, okay, 5 times 750 plus 1,000 and fill that in. 10 times 750 plus 1,000 and fill that in. But that wouldn't be the smart way to do it, would it? What would be the smart way? Table. Control T. I already have all three of those equations in there, right? So I just need to fill out my table. Here's my first function. So for 5, 4750. For 10, 8,500. For 20, 16,000. And for 25, 19,750. Then jump over to F2, which is our B of x, right? So this is 17,000. And look, you can look down here at the bottom to know the exact value. So that looks like 6 cents. So 20 would be $9,646.29. And 10 would be 3,105 and 85 cents. And then 5 would be $1,762 and 34 cents. And then jump over one more column to F sub 3, or F of 3, and this is C of x. So 5 is 12,500. 10 is 19,000. 20 is 18,100. And 25 is 8,500. So after 5 years, who had the most? Who had the most? A, B, or C? Carl. Didn't Carl have the... What's up? Did I miss one of my places? Which one? This one's supposed to be 17,000? Exactly 17,000? Thank you very much. Okay. So after 10 years, who had the most? Carl. After 20 years, who had the most? Carl. After 25 years, Alan. Okay, so far? Okay. It is given that Carl had $1,000 after 28 years. How much did the other siblings have at this point? Wait, can I still use the table for that? What am I looking for on the table? 28 is my x value. So when 28 is my x value, A is Alan, right? The first one? And Alan had 22,000. And Bernice had 23,883 and 87 cents. I could take this time to make some sort of sexist comment that it is obvious that the woman has the most money at the end, but I won't do that because some people don't appreciate that. Use the graphs of these functions on a calculator to answer the questions that follow. So sure enough, we still have the calculator, right? I'm going to hit Control T to make my table go away so that I can see just my graph again. After approximately how many years did Alan and Bernice have the same amount of money invested? Isn't it when the lines cross? That's a very good question. Can somebody answer that for her? Yes, right? So we have to figure out which ones we're talking about. Alan was the line and Bernice was the exponential. So where are these crossing? Well, first of all, they cross right here, right? Is that what we're talking about? No. After how many years? So we need to go on. So I'm trying to look when this line and this exponential function cross, and it's going to be way over here, isn't it? How are we going to figure that out? Menu, Analyze Graph, Intersection. Now remember, we've done this lots of times before, right? But it's different this time because it's asking me which graphs. Because only time we've ever done this in the calculator before, I think we've only had 2. Notice when I put my cursor over one of the graphs, it gets really dark. So I need to move my cursor over the graph and click on it. And then it says the second graph. So I need to move my cursor over the second graph and click on it. And then it gives me the line that we're used to. Okay? So I want that one and that one. So explain to me what it means. Because the answer that it gives me is 27, 2.12 E4. After 27 years, they both had, that's what I heard, and it's right, so I started writing it down. So how do I finish it? How much though? Because it asked me how much. What was the amount? You're right, they both had the same amount of money, but how much? What does this mean? 2.12 E4. It has 4 decimal places after the decimal. So the decimal is actually not there, and there's 4 decimal places. What number is that? 21,200. And for the record, that is an approximate. It rounded it for you. But for now, that's good enough for us. Okay? Because you can actually go to the table and look and see how much they had, because it's 27 years. It's exactly 27, right? Okay? And if you did that, you'd notice it's a slightly different number, but it's pretty close to that. Okay? So what about number 6? After approximately how many years did Alan and Carl have the same amount of money? Well, that's not going to be any different, is it? I'm still doing it exactly the same way that I just did the last one. Menu, Analyze, find the intersection. But this time I'm finding the intersection of Alan and Carl. Alan being the line, which is right there, and Carl being the parabola, right? So once again, we're not talking about the original point that they all 3 started at. We're talking about this later point that they intersected at, right? Okay, so here's the problem. I can't read mine either. Can you read mine? So somewhere right here. Oh, look, do you see my little hand? Not my actual hand. It's right here, obviously. But the hand on the calculator, see, it's like this. I want it to grab. So I'm going to press Control and then the middle click button. Did you see the hand close? Now I can move that to somewhere where I can read it. Like right there. And that says 20.5, 1.64 E4. The calculator tells us all sorts of interesting stuff if we know how to read it, right? So how do we read that one? After 20.5 years, They both had the decimal was here. How many places am I supposed to multiply it by? I'm supposed to move it over 4, right? E4. So 16,400. Again, that's a rounding for you. If you went and looked on the table, which would be difficult because it's a 0.5, but you could adjust your table, you would see that it's actually 16,375, but you understand why the calculator rounded it up for you. Yes? Okay. So one more. After approximately how many years did Bernice and Carl have the same amount of money? Once again, same kind of deal, right? Menu, analyze, the intersection. Which two graphs are we dealing with this time? So the parabola and the exponential. And their intersection is going to be right here somewhere, isn't it? Can everybody see that okay? The point that I see is 22.7, comma 1.31 E4. Yes? So that means after 22.7 years, you know what this kid said earlier? He said after 22 years and 7 months. What did I say? No. Right? It's 0.7 of a year, which is not 7 months, because there's 12 months in a year. It can't just easily go over like that. We could figure out that it's probably about 8 months if we want to do the math, but this is perfectly acceptable right now. Okay? They both had 13100 $13,100. Yes? One of the problems above can be solved algebraically. That is without a calculator. Which one do you think it is? Can you solve the intersection of a parabola? Let's see which one was first. Alan and Bernice. Oh, a line and an exponential. Because with an exponential, you'd be having to take the log. And can we do that without a calculator? Not successfully, right? So the second one was Alan and Carl. So a line and a parabola? Maybe. Well, my other choice is Bernice and Carl. That's the exponential and the quadratic. Once again, exactly. Once again, we'd have to take the log. So which one do you think it is? Alan and Carl? How would I try to solve that algebraically? If Alan is y equals 1,000 plus 750x, and Carl is y equals negative 100x squared plus 2,800x plus 1,000. If they both equal y, don't they both equal each other? So I should, yeah, that's exactly right. Set them equal to each other. Okay? So Alan was 1,000 plus 750x, and Carl was so negative 100x squared plus 2,800x plus 1,000. How would I solve that? We got to get it equal to 0. Some of you are noticing this is a quadratic because you're mouthing it to me instead of saying it out loud. That's okay. We're still working on that, right? Okay. It's a quadratic, so we got to get it equal to 0. So let's subtract 1,000 on both sides. And let's subtract 750x on both sides. When we do that, I get 0 equals negative 100x squared plus 2050x. And that's it, right? Because that's a 0. How do I solve that? Well, I could take out the greatest common factor, right? What's the greatest common factor of these two? For sure an x. And let's take out a negative x so I don't have to worry about anything else, right? Is there anything else I could take out besides an x? I could be really brave and take out 100, can't I? I know that'll give me a decimal here, but are you okay with that? So if I take out, let's say, 100x, that leaves me with x minus 20.5. We okay so far? I know it's been a while since we've done quadratics, but we've done a little bit here and there, so I'm hoping you guys are still with me. Are you? 3 of you. Excellent. Okay. So 100x equals 0 and x minus 20.5 equals 0. So this is x equals 0. What's this one? If I add 20.5 to both sides, x equals 20.5. Look. Look what we got. Exactly the same answer. We are amazing. If you weren't, I would tell you. Okay? Any questions about this? Okay, so I need this worksheet completed for homework. Make sure you have it completed by the time you come to class tomorrow. Otherwise, have a great day. Peace.